Welcome back. This lesson we're looking at finding the antiderivative, or what we call the integral. So if we think of differentiation, all the rules that we've learnt, so chain rule, product rule, quotient rule, all those fun things, we know that we can find the derivative of a function using a nice shortcut. So let's do a nice and easy one to start off with. Let's say we had 4x cubed, and we say to find the derivative f dash x, we multiply the power of x by the coefficient at the front, which gives us 12, and we drop the power down by 1, so it become 2. When we're trying to do anti-differentiation, we're trying to go from this answer back up to the original function. So, how do we do that? We can look at the relationship here, and I'll show you the formula at the end. Actually, I'll show the formula right now, and it'll look pretty scary for you at first sight. So this symbol here, we call the integral. We're trying to find the original function of some function x to any power, and we always write what variable we're trying to find it with respect to. So we'd find this is the integral of x to the power of n with respect to x. It would equal x, where the power is n plus 1, divided by n plus 1 plus c. So if I lose you, at the very least, if you can sub the values into this formula, it'll work. So let's look at our original example, 4x cubed, 12x squared. We're trying to find some number that, when multiplied by the power of x, would equal 12. Now, that just means two factors of 12. That could be 12 and 1, could be 4 and 3, could be 6 and 2. I don't know. So I have to know, at the very least, the power of x. And I notice that now it's 2. I know when I'm doing the derivative, all I'm doing is taking it down by 1. So the first thing I do is I look at that power in the answer and go, well, it's a 2. I'm going to plus 1 and make it 3. So 3 times what would give us 12? Must be 4. So that tells us the coefficient at the front. So let's use this notation doing that first example. So if I wanted to find the integral of 12x squared with respect to x, so that's my answer from here. In this case, looking at that formula, I can see that I have power of 12 at the front here. I've got x and the power is 2. So my final answer at the top here, I'm going to have x, where n was originally 2, plus 1. And I'm going to divide it by 2 plus 1. And my 12, thankfully, I've got 12 at the front here. I can write that out the front of the integral. So any constant, I can just take out the front. So I'm going to multiply this whole thing by 12. Let's simplify and see what we get. We'd get 12. Oh, there it is. We'd get 12 times x to the power of 3, all divided by, let's cancel. Oh, what's happened there? Oh, that's better, it's back working. So we'd get 12 times x to the power of 3 divided by 3, which would equal 12 divided by 3 is 4, x cubed. And I've got a plus c at the end. Okay, so we go, well, that doesn't look exactly like my first answer. So what's happening there? When we're finding the derivative, let's look at another one. F of x, let's say it's just 3x7 and plus 5. When we're finding the derivative of this, f dash x would equal 21x6, and the plus 5 drops off. If I was to find, let's say, another equation, 3x7 minus 4, to find the derivative, 7 times 3 is 21, x power of 6, and the 4 drops off. And you go, oh, hang on, two different equations give me the same derivative. Because what's happening when you're plussing and minusing a whole number at the end here, it's just giving you a vertical translation up or down. The gradient at any given point is staying exactly the same. It's just been moved up or down along the axes. So there's a number out there, and it doesn't matter what it is. When we derive it, it's going to disappear if it's a constant number. So when we're going the other way and finding the antiderivative, there could be a number there, or there might not have been. In this first case, we had 4x cubed. There wasn't, and the derivative was 12x squared. But if I didn't know that, and I was just asked to find the antiderivative of 12x squared, I have to say it is 4x to the power of 3 plus a constant out there. Now that constant could be 0, like it was in this example up here, but I don't have enough information to find out yet. If I was given a point to sub in, I could sub that in to find c and check what that constant would be. So let's look at one last example and see if we can figure it out. So let's look at this example here. We've got dy dx equals x squared plus 2x, and we know when y equals 2, x equals 0. So now we have a point that it goes through. We should be able to find whatever that constant is. So let's go through it nice and slowly together. If we want to find y in terms of x, now we're going the opposite to derivative. So instead of dropping the power down by 1, we're going to move it up by 1. So first thing I'm going to write here, and same thing with the derivative, let's do one term at a time. So x squared, I'm going to raise the power up by 3, and rather than timesing it like I did when I found the derivative, to do the opposite of times is divide. So I'm going to divide it by that new power. So x cubed on 3 and 2x, I'm going to raise, let's just write 2x first. I'm going to raise my power up. So at the moment it's x to the power 1, so I'm going to raise it up to the power of 2 and divide by my new power. Then plus c out the end. So let's tidy this up a bit. I'd have y equals x cubed on 3 plus, and the 2's will cancel off, plus x squared plus c. And now to find c, I have to sub in what I know from the equation. I've got the point 0, 2. So, and 0, 2 is a point. So let's sub that in. So 2 is our y value. X is 0 for this. So we'd have 0 cubed on 3 plus 0 squared plus c. So let's try and rearrange and solve that. So that'd be 0 plus 0 plus c equals 2. So therefore c equals 2. So my final answer, therefore y equals x cubed on 3 plus x squared plus 2 is my final answer. Now, don't trust me, that's fine. If you want to check your answers, just find the derivative of this function now using the same techniques we've learned in the past. So the power is 3 times a third, drop the power down by 1. So x cubed on 3 would be 3 times a third times x squared. The next one would be 2 times x to the power 1, and the c would drop off. 3 times a third is 1, so I get x squared plus 2x. And that's what I started with. So I know that my answer must be correct. Okay, like I said, the rule looks a little bit daunting at first. If you can follow it and just plug it in, then you should be fine. But all you're really doing is a reverse of finding the derivative. So instead of dropping the power down by 1, first raise the power up by 1. Then instead of multiplying the power and the coefficient, divide the coefficient by that new power. And that would give you your original function when you've been starting with the derivative. Don't forget about your plus c. And if you're given a point, you can sub it in to find c. If you're not given a point, you're going to have c in your answer, because that could be at any vertical translation there. All right, all the best. I'll put up another video with a few more worked examples of some trickier questions.